So for number 1, we should have gotten 4, 8. Are you good with that? Do we need to work anything out there? Do you have any questions? And for number 2, you should have gotten 5, 2. We all good? Any questions at all? Anything we need to go over? Need to see any of that worked out? So we're good? We're experts at substitution now?
Yes.
Okay, so on the back side, this is another way that we can do them. So substitution works out very nicely when you've got x equals something or y equals something. But look at what we've got now. Are any of these equations like that? Or is any of these systems set up like that? No, so we're going to try another method. Now this is called elimination. So what do you think is going to happen? You're going to eliminate something, yeah? So we like to do elimination when you've got your variables like in front of x or in front of y, you've got the same number, but the opposite signs, okay? So that's what's got to be going on in order for something to eliminate. So that's what we're talking about up here. So we can add the two equations together. We're trying to get rid of one of our variables. So again, you've got to have the same number and the opposite sign for that to happen, which is what is happening here. If it's not going to work out nicely, then you'll have to manipulate it a little bit. Tomorrow or Monday, we'll do a lot more manipulating, trying to get it in a way that's going to eliminate. But today, you'll just have to multiply by like -1. So if we look at the first example here, do we have numbers in front of x or y that are the same number, opposite sign? In front of x, what are our coefficients? 1 and 1. So those are the same number. Are they opposite signs? No. What about in front of y's? We got +1 and -1, right? That's the same number, opposite signs. So that means that when we add these two equations together, those y's are going to cancel out, right? So if we add x plus x, what do you get? 2x. So if you add 1y and then subtract 1y, what happens? Cancels. It eliminates, right? It goes away. And all this equals, what is 5 plus 1? 6. So now we've just got 2x equals 6. Super easy to solve for x, right? What do you do to get x by itself now? Just divide by 2. And what does x equal? Good. So we know x equals 3. We're halfway done. We still have to find what? How are you going to do that? Plug back in. We can use either equation, okay? Either one you want. Do y'all want to use top or bottom? Top. So the top equation was x plus y equals 5. So in place of x, we're going to put a 3. So we'll say 3 plus y equals 5. How are we going to figure out what y is? Subtract 3. So y equals what? 2. How do you write your answer? 3, 2. Remember, we got to put that as an ordered pair. Questions on any of that? Are we okay so far? Yeah? Y'all want to try another one? Okay, let's do one that's a little bit harder. Well, really not any of these are much harder. Which ones y'all want to do? We'll do half together and half by yourself. 5? Ooh, we'll do 5 and 4. Those are good. Alright, so if we look at number 5, let's do 5 first. We said in order for something to eliminate or like cancel out, we've got to have the same number but opposite signs in front of the variable, right? So if we're looking at m's, do we have the same number opposite sign in front of m? Do we have same number opposite sign in front of n? No, but we do have the same number then, right? So what if we multiplied one of those equations, the entire thing, by -1? Then would we have opposite signs? Yeah, so let's do that. Do you want to do top or bottom? I'm going to do top. So we're multiplying the entire top equation by -1, and we're only doing that so that something will cancel out. So when we do that, instead of a +1m, we're going to have -1m. Instead of a +2n, we'll have -2n. And instead of -2, we'll have +2. So now if we look at our new equation and the other equation we have here, we can add those together and something's going to cancel, right? So let's add these equations together. What is 4m minus 1m? 3m. What is 2n minus 2n? Cancels out or eliminates. And then we've got negative 17 plus 2. What's that? Negative 15. Divide by 3, we'll know what m is when we'll be halfway done. What do we get for m? Negative 5. Again, we got to be careful with your signs here, y'all, because if we get one sign wrong, it messes up the whole answer, right? So we know that m is negative 5. We still have to find n, so you can plug back into one of your original equations. It can't be one that we've changed at all. So one of your original, one that's already on the page. So y'all want to use top or bottom? Top. I think top is easier just because there's less numbers in front of everything going on, right? So we'll plug into the top of the original equation. So we're going to have negative 5, because that's going in place of m, plus 2n equals negative 2. How are we going to figure out what n is? At 5. So we'll have 2n equals, what is negative 2 plus 5? 3. What do we do from there? So divide by 2. So what does n equal? Just 3 over 2. How would we write our answer? What comes first? M or n? M, right? And in your ordered pair, usually we have x then y, right? And alphabetically, x still comes first. So m is going to come first. So if you've got variables other than x and y, you'll still just write your answer in alphabetical order. So we'll put m, negative 5, then n, which is 3 over 2. Now fractions are totally okay here. So let's think back to yesterday when we were graphing. And we had a point that was some of us messed up lines, and we had points that were not on a good point, right? And it was like a fraction, and we're like, oh no, this isn't right. Fractions are okay now. Would you be able to find this point easily if you were graphing it? Probably not, because it's not at a good point. It doesn't cross exactly at a good point. So you'd be estimating there, right? So this is going to be a better way to solve than graphing, so we can get exact answers. Does that make sense? So this is why we got to have other tools to work these problems out. Do we have questions on anything that we did here? Do we need to do another easier one before we do a tricky one again? Y'all just ready for the hard stuff? Yeah? Okay. All right, so let's look at number 4. Now, the ones that we've done before, we've had m on top of n on top of n, constant on top of constant. Is this one lined up that way? No. So we're going to have to manipulate a little bit so that it does look like that. So how could we make this equation look more like that? We could solve for y here, and then we could do substitution. But we want to do elimination, so we need to have x's and y's on the same side. What do we need to do, Ashley? We could even do that too, but again, that's substitution, and we want to do elimination here. So we want to get x's and y's on the same side, so we're going to move this x over. So that top equation is going to stay the same. I'll rewrite it later. We'll have negative x plus 4y equals negative 2 now. So this is in standard form. At the top of your page up here, it tells you what that is. This right here is standard form, so when you've got x's and y's on the same side, your equations have to be in this form for us to do elimination, so that's why we're changing this one around here. So I'm going to rewrite the top equation just so everything's lined up nicely here. We'll have 7x minus 4y equals negative 19. I can try. Let's see. Is that better? Alright. So looking here now. Do we have, if you look at your x's, do we have same number of opposite signs in front of your x's? Do we have same number of opposite signs in front of your y's? Yes, so we know that something's going to eliminate. So let's add these two together. What's negative 1x plus 7x? 6x. What's positive 4y minus 4y? Cancels out. Then we've got negative 2 plus negative 19. What is that? Is that okay? What do we do from there? So negative 21 over 6. Will that reduce at all? Are you sure? Divide everything by 3. Yeah. What's 21 divided by 3? What's 6 divided by 3? 2. So that's what we'll have for x. And again, fractions are totally okay here. But would you find negative 7 over 2 easily if you were graphing? Probably not, right? We'd have to estimate where that falls exactly. So we've got x. What do you still need? We still need y. So we're going to have to plug back into one of our original equations. Do you want to use top or bottom? Bottom one? Okay. So we'll have 4y equals x, which was negative 7 over 2, minus 2. So we're going to have to do negative 7 over 2 minus 2. Before you can subtract fractions, what do you have to have? Common denominator. So our denominator needs to be 2. So you're going to have to multiply by like 2 over 2. So that's going to be the same thing as negative 4 over 2. Is that okay? So what's negative 7 minus 4? Negative 11 over 2. That's what 4y equals. How are we going to get y by itself? Divide by what? We're just dividing by 4. Just divide by whatever's in front of y. So we'll have y equals. Now over here, this is where it gets a little tricky. If you're dividing by a fraction, you're multiplying by the reciprocal. So that's going to be 11 over 2 times, if we have 4, that's like 4 over 1. What's the reciprocal of that? When you flip it, what do you get? Somebody said it. Natalie, what do you get? 1 over 4. So then when you multiply straight across, negative 11 times 1, what do you get? 2 times 4 is 8. So y is going to equal negative 11 over 8. So this one was super messy. We need to write our final answer as an ordered pair. So what did we get for x? Negative 7 over 2. And for y, what did we have? Negative 11 over 8. And that's our final answer there. We would never find that on a graph. I wouldn't anyway. That would not happen. Is that okay? Do you have any questions there? Anything we're not sure about? Don't know how it worked the way it did? So are fractions okay here? Absolutely. So please do not freak out when you get fractions for your answers. It is okay. Do we need to do another one together, or are y'all ready to try the rest on your own? We're good on our own? Yeah? Alrighty, so I'll let you try 2, 3, and 6, and we'll go over them in just a minute.